Hi guys, and welcome to another episode of Math Made Easy by Mrs. Roberts. Funny story about this video. I actually already recorded this video once, and turns out my husband was playing a joke on me and turned the mic off. I didn't figure that out until after I posted the video, and someone was like, hey, there's no sound. So let's see how take 2 goes. So in this video, we're going to find general and particular solutions. We're going to do 2 things. We're going to do the general and then the particular. I would recommend having a calculator in front of you and this set of notes. So if you haven't taken the set of notes yet, pause the video here and make sure that you have these 3 things written down. Okay, so what these notes are telling us are how to find the exact values for which make functions true. And when we're solving, that's really important. So the first set of these are theta and x, so whether you're in degrees or radians. And it says theta is the arcsin of the argument. Take the inverse sine of that argument and add 360 degrees. 360 degrees n is saying that you can add 360 degrees as many times as you want, and you're going to be in exactly the same spot. Those are called coterminal angles. Now, this other piece of it is because the unit circle is this cool thing where it repeats, but it also has reflections. And so sine is actually reflective over the y-axis. All of the values that are reflected over that y-axis are going to give you exactly the same thing. And so it's important to keep those all in mind. Cosine, the additional angle is that plus or minus, and so it's reflective over the x-axis. So it's going to reflect this way here, and that's what the plus and the minus is. And then tangent, it just has a different period. Tangent's period is 180 degrees. So let's go ahead and start with an example. So we'll call this example 1. In example 1, we want to figure out what is theta of the arcsin of 0.7. So what is the theta of the arcsin of 0.7? So because we're looking at the arcsin, we are going to be looking here. Now, the other piece of this information that's important is the domain in which we're looking in. And so we're going to say that theta is an element between 0 degrees and 720 degrees. That's important for the particular solutions. We only care about 0 to 720 degrees. So theta is the arcsin. And so what we're saying is that sine of theta is 0.7. Sine of theta is 0.7. And so what angles is this true? Now, what we could do is we could just immediately go to this and we can start applying what makes this true. But I think that what's even better is to go into the graphing calculator and get a visual representation of this. And so I'm going to say y equals sine of x. And I want to know specifically when x equals 0.7. Not x, y, sorry, when y equals 0.7. And so you will see on here that there are all these different times that this crosses. Now there's something else very important that we need to do. This right now is in radians. When you click this wrench up here in the right-hand corner, you can change it to degrees. Then you want to change your x-axis. So we're looking from 0 to 720 degrees. That's what we care about. So everywhere this crosses is a particular solution. So at 44.4 degrees, sine equals 0.7. At 135.6 degrees, sine equals 0.7. At 404.4 degrees, sine equals 0.7. And at 495.6 degrees, sine equals 0.7. And so that is what we are searching for. So that's really good information to have. Now, let's go about actually solving this. Let's go about using our tools, using our notes to solve this. So it says that theta is the arcsine of A, which we would say is the inverse sine of A. And then to make it a general solution, we're going to add 360n, meaning add 360 as many times as you want, and you are going to get exactly the same answer. So let's try this. We want to figure out what is the inverse sign of 0.7. So the inverse sign of 0.7, let's go ahead and go to our Desmos. To find the inverse sign, click this button, hit Functions, and then you'll see the inverse sign. And then you can type in 0.7, and it gives us 44.4 degrees. So this is 44.4 degrees. And then what this equation is telling us to do is add 360 degrees n. That is half of the general solution. That's half of the general solution. The other half of the general solution comes from this piece right here. 180 minus 44.4 degrees plus 360 n. And that is because of the reflective properties of the unit circle. So let's go ahead and go here, and we'll say, okay, what is 180 minus 44.40? That wasn't a point, 0.427, and we're going to get about 135.6 degrees. And so we'll go ahead and we'll write that right here. Or, because that's what it says right here, or 135.6 degrees plus 360 n. That is the general solution. And so what we did was we just used this first rule here. And the reason why that rule works is because of the reflective properties of the unit circle. And we talked about those a little bit earlier in the previous video. Okay, so we did A. Let's put a little A next to this so that you know that was A. So the next component of this is finding all the particular solutions that are in the given domain. And we actually already did that. That was right here. So we have our first particular solution is 44.4. Our next one is 135.57, so 135.6. And then when I add 360 to this, I get 404.427. And when I add 360 to the 135, I get 495.6. So those are all the general solutions that are in that given domain. Now, there are a lot more solutions. So I could keep clicking, and the next one that we get is right here. But 764 is outside of our given domain. And so we are not going to include that one in our list of solutions. So our particular solutions within the given domain are going to be theta equals 44.4 degrees, 135.6 degrees, 404.4 degrees, and 495.6 degrees. There we go. So, using this rule right here, we were able to solve for a general solution, which the general solution is always going to have a plus 360n or plus something n. If the period changes, that changes things. And then we were able to find the particular solutions, and particular means actual points in this given domain. Okay, let's try one that's not sine. Let's try maybe a tangent one. So let's call this question 2. And let's say that theta is arctangent of -4. So theta is arctangent of -4. And so because we're looking at arctangent, we are going to use this here. And we're going to be in that same domain of 0 degrees to 720 degrees. So if you want to analyze this first, you could go over to Desmos. And because we're doing an arctangent, go ahead and make your first equation tangent of x. And then what we know is that tangent of x equals -4. And then I'll exit out of these ones because that was for the last problem. And now, anywhere these cross are particular solutions. So the arctangent of -4 is 104. The arctangent of -4 is 284. The arctangent of -4 is 464 and 644. So all of those are particular solutions that are within that given domain. So now let's solve this algebraically. Now what this rule tells us to do is to take the inverse tangent and then add 180 degrees n to that. And the 180 degrees n comes from the period of tangent. It repeats every 180 degrees. So we need to find the inverse tangent. And to do that, we'll go ahead and plug this into our calculator. Click functions, inverse tangent, type in -4, and we get -75.96. So -75.96 degrees. And to make this a general solution, we would say theta equals -75.96 degrees plus 360 degrees, not 360, oops, 180 degrees n. And this is 180 degrees because of tangent and the period is different, and because the rule tells us to use 180 degrees. Now, we want to find our particular solution. So this will say the particular solutions between 0 and 720. You can do that just by clicking on your graph, here, 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 or here. Or you can even make the equation where you say -75.96 plus 180x. And then you can change this into a table. And then you can look up until you get to 720 degrees. So these are giving us exactly the same answers as clicking over here. That's what you're going to find. These are exactly the same answers. But it puts us in this nice clear format for us. So we only care between 0 and 720. And so the first one is going to be at 104.04 degrees. So theta equals 104.04 degrees. The next one is going to be at 284.04. Oops. And the next one, oops, I don't know what I did. Sorry, guys. Okay, the next one is going to be at we did 284, so we're at 464.04. And then 644.04. And this last one, that 824, that one is outside of our domain. And so that one will not be included in our answers. So what I would like you guys to do now is I would like you to try a few of these problems. So let me write down just a few of them for you. Go ahead and try them out and see how you do.